OPSEC, operational security, was originally a military term used to describe how well critical information was hidden from enemy intelligence. However, on the internet, the term is used to describe how much sensitive or private information about you is exposed to the conceived bad actor in a given context. The more information someone can get about you, the worse OPSEC you have. Before doing anything, you first have to build what is known as a threat model. The goal of threat modeling is, in its simplicity, to help decide the best course of action, to not go overkill, but also to effectively keep the information safe. Threat modeling can be thought of as the following set of questions. What data am I trying to protect? Who is trying to get the information, and what is their capability? How critical is the information we're trying to protect? After you've considered all of the above questions, you can start to plan and implement appropriate protective measures. The threat model for the average Joe who browses Netflix now and then and checks his Gmail for new emails daily is very different from that of a government whistleblower. For Joe, the biggest threat would be his accounts getting compromised or his identity being stolen. Joe doesn't need to worry about the government subpoenaing his information from Netflix and going to jail, because the information gotten from Netflix led the police to find out his address. But for the whistleblower, this is something that has to be accounted for. Your threat model plays a huge role in deciding how to maintain your OPSEC, but there are some universal OPSEC guidelines principles. Separating things. An example of this would be using separate users for work and gaming. Minimizing attack surface. Keep track of shared information and delete data and accounts that are no longer needed. For example, if you stop using an online account, delete the account, and if you're in the EU, submit a GDPR data deletion request. https://gdpr.eu/right-to-be-forgotten/. Implement security and privacy measures like disk encryption. Alternatives to popular services. Google Play, F-Droid, and Aurora Store. Google Chrome, LibreWolf. Google Search, Startpage or DuckDuckGo. Default Windows email client, Thunderbird. Office 365, LibreOffice. Visual Studio Code, VS Codium. WhatsApp, Signal. Securing internet traffic. When you use the internet without any kind of protection, your DNS requests, website names that you visit, the servers you communicate with, and all unencrypted traffic is visible to your ISP, your gateway, and any rogue devices that want to intercept the connection between you and your gateway. Tor is like a silver bullet anonymity-wise for all the above-mentioned problems. When you use Tor, your internet traffic, including DNS requests, is routed through 3 nodes, which are like proxy servers run by volunteers. This means that no single entity can track users through the network. Inside TOR, you can visit hidden services. They are normal services like websites that you can only access from inside the Tor network. Drawbacks. TOR is very popular, and unless you're using a bridge which hides the fact that you're using TOR, your ISP, etc. can see that you're using TOR, which might garner some unwanted attention. All Tor exit nodes, the last node that connects to the server, are public, and because of that, a huge number of websites will bombard you with CAPTCHAs, bot verifications, or block you from visiting the site entirely based on if you're using a known Tor IP. Although very rare, there have been some exploits that the police and governments have used to de-anonymize Tor users. VPNs, virtual private networks, are much like a proxy server. They encrypt and route all your traffic through their servers to the destination, so you don't expose your IP. Note, almost every legitimate VPN company is paid. Free VPNs will probably end up selling your information. A good thing about VPNs is that their servers are usually not publicly available and aren't as often abused, so you won't get as many bot verification screens and Cloudflare access denied errors. Almost all VPNs collect personal information, so I can't really recommend them, but there's one outlier, Mulvad VPN, https://mulvad.net/. Drawbacks. A VPN is only as secure and private as the company behind it. If the company wants to sell your data or cooperate with the police, they can absolutely do that, and all the benefits that the VPN offers become void. They cost money. DNS over TLS. A vast majority of websites already use HTTPS and host the site in the public cloud, making the server IP address not directly associated to the website. If you aren't afraid of your IP leaking, you might not want to add a proxy at all instead, but instead, only encrypt the DNS requests that expose what website you are going to. This is where DNS over TLS comes in. Like the name suggests, DOT is DNS just over an encrypted connection. The encrypted DNS I have most faith in would be Quad 9. If you aren't going to use any VPN or anonymization network, I highly recommend using DOT. I2P is a relatively unknown anonymity network very similar to TOR. The main difference between I2P and TOR is that Tor nodes are run by volunteers, but in I2P, you automatically become a node when you connect to the network. I2P has other cool features as well, which I won't get into now, but all in all, it's a very cool network and deserves more recognition. Hackers also employ the practice of compartmentalization. By dividing their operations into separate, isolated parts, they minimize the risk of exposure. If one part is compromised, the rest of the operation remains secure. Regularly changing passwords and using strong, unique ones is another OPSEC strategy. This reduces the likelihood of unauthorized access to accounts and systems, protecting sensitive information from being compromised. Social engineering awareness is also vital in OPSEC. Hackers must be cautious about the information they share, even inadvertently, to prevent adversaries from piecing together clues that could lead to their identification. In conclusion, OPSEC is an essential practice for hackers to maintain anonymity and protect their operations. By employing these techniques, they can effectively safeguard their activities and avoid detection by security forces.